Okay, we're going to look at April 1st. This is the second of two videos. And what I wanted to do is I wanted to spend some time here practicing the constant growth rate model and kind of auditing it in a sense. And then there'll be an opportunity for you to do an example yourself at the end, and as we go through it as well. And so I'm going to have a pen and paper and calculator handy. And of course, you could pause and start it again and work through it several times to learn the material. The constant growth model, that was the D1 divided by RS minus G. And so we'll see it here in a bit. It's for valuing a common stock, but specifically a common stock whose growth rate historically goes up by about the same percentage each year. Like, in other words, every year the dividend increases by like 3%. And so if we see that's historical, like historically, we see that a company increases its dividend by a certain percentage every year, and we believe that's going to continue into the future, we'd use this model to value a common stock or its common stock. So we use this model if we expect a firm to increase its dividend by a certain growth rate each year. Perhaps historically that's what we saw that it's been doing all along, and we have no reason to think it's going to change. Remember, years ago I looked at Johnson & Johnson's dividend. I think we actually used it in class and saw that the dividend growth rate was about the same percentage year after year. In other words, each year they increased the dividend. I think it was by 6.79% in our slides. So for example, the dividend this year is going to be $1 in 2020. Next year it'll be $1.03. So every year it'll go up by 3%. Looking at historical dividend data, we find that firms actually do that. So this model is very relevant. If we find a firm that increases its dividend at approximately the same growth rate year after year after year, and we expect it to continue to do that, we'd break out this model to value the stock. The constant growth rate model computes the present value. Remember, we're valuing something. We valued a firm with a free cash flow model. We valued bonds. The present value of the cash flow that something gives you, like in this case, a common stock, a security, the present value of it is what its price should be. When I want to estimate the price of anything, I find the present value of all the money it's expected to pay out throughout time. And that's what we're doing here. It's just that the dividend is not expected to stay the same year after year. It's expected to go up at a constant growth rate, like 3% per year. So there's the model. You take that. Now notice that it's PO. That's the price this year, 2020. PO equals D1. That's the dividend next year. So the dividend with this model is always 1 year ahead of the price. So you take D1 divided by RS, that's the required return of the stock. That's what we believe the stock should return. That's a fair return for the stock based on how risky the company is. Minus G, the dividend growth rate. So D1 is the dividend expected next year. RS is our estimate of what the stock should return. It's got like 3 names: a required return. RS could be called required return, fair return, market return. G is the expected dividend growth rate. So notice the dividend, again, notice the dividend is 1 year ahead of the price. The price now, PO means this year, the price of the stock in 2020, equals the next dividend. That's D1 is next year's dividend. So, and we've done this before, so you try a problem. How much should a stock sell for today, given the dividend this year is $2. The dividend's expected to increase by 2.5% per year into the future, throughout time, forever. The required return on the stock is 11%. That's what we believe is a fair return. In other words, we're going to load that into the model, and the model's going to tell us what price. It'll give us back the price that causes that dividend stream to yield 11%. So you go ahead and work that out, pause it, work it out, see if you get the right answer, and then come back and check your work. And there's the answer. So D1 is this year's dividend, $2 times 1 plus the growth rate. So that's, it's actually next year's dividend is $2.05. So next year's dividend is this year's dividend times 1 plus the growth rate. And then in the denominator, we take the required return minus the dividend growth rate of 2.5%. And so that price, that stock today is worth $24.12. If somebody buys the stock today at that price and collects the dividends going forward, she or he should get a 11% return. That's the price that should make that dividend stream $2.05 next year, 2.5% more than that the year after. That's the price that should make that dividend stream yield 11% to someone who purchased the stock for $24.12. That's the price that should make it yield 11% to someone who buys it at that price. So today, we believe this stock is worth $24.12. Here's another problem to try. How much should our stock sell for in 1 year? Now remember, the dividend is always a year ahead of the price. It's the same information. It's the same stock. The dividend this year is $2. The dividend is expected to increase by 2.5% per year into the future, indefinitely. It's a stock. There's no maturity date as with a bond. The required return is 11%. So go ahead and try it and then come back. Remember, the dividend's always 1 year ahead of the price. Here I'm trying to calculate P1, the price in 1 year. So I better use D2. Go ahead and try it, pause and try it, and then come back. And there's the answer, $24.12. So that's what we think the price of the stock will be next year, $24.72. That's what we believe the price of the stock will be next year. So let's calculate, this is new, let's calculate the holding period return. Actually, we did do this with bonds, I think, in the bond homework. Somewhere back there we did this. So we're going to calculate the holding period return, but for this stock. I don't think we've ever done that before. I don't remember doing that before with stock in our class. So what annual return would a person earn given they buy the stock now at PO, which we calculated 2 slides ago, collect D1, the coming dividend in the coming year, and sell it a year from now when it's worth P1? So I did that. The holding period return is P1 minus PO plus D1 divided by PO. It's the increase in price during the year plus the dividend divided by what we paid for it at the beginning of the year, PO. So PO appears twice in the equation. It appears in the numerator, in the middle there, and appears in the denominator. And look at that. The answer is 11%. And that's interesting because the required return of the stock is 11%. And so what we're showing, we're kind of, in a sense, auditing the model. We see, okay, the way that this all pans out, if somebody does buy it now and collects the first dividend and sells it in a year for more than the $24.72, which is more than the $24.12 they bought it for, indeed, they get an 11% return. So that is the required return that was given in the problem. We were given RS equals 11%. We see that the stock actually does return that. So it kind of fits together appropriately. It does what we expect it to do. Someone who buys the stock for $24.12 at the beginning of the year, collects the $2.05 in the coming year, D1, and sells it at the end of the year for $24.72. They sell it for $24.72 at the end of the year, P1. They indeed get an 11% return. So now I'm going to partition the required return that we just did into 2 components, the dividend yield and the growth rate. So the HPR, that's the holding period return that we just did, I'm going to partition that into the dividend yield and the price appreciation yield, or the growth rate, G. So I take D1, the dividend in the coming year, divided by the price now, plus the price appreciation divided by the price of the stock right now. And you get $2.05 divided by 2412. And then you have the price appreciation from 2412 to 2472 over the period of a year. And look at that, the dividend yield is 8.5%, and the price appreciation or growth rate is 2.5%. So the dividend yield is 8.5%. The growth rate, which is the growth rate of the dividend, is also, that's what we're really catching here too, another like insight. What we're seeing here is the dividend growth rate of 2.5% is also the price appreciation growth rate. So if I use a dividend growth rate of 2.5%, I'm also implying that year to year the price of the stock will rise by 2.5%. So somebody who buys that stock gets a dividend, and the dividend yield is 8.5%, and the price of the stock goes up. So there's really two ways to make money with a stock, and we're looking at that right now. One, it pays a dividend. If it does, some stocks don't, but this one does. It pays a dividend. And number two, the price of the stock rises. And so what we see here is the dividend growth rate, the dividend yield, plus the growth rate in the dividend, which is also the growth rate in the stock price, equals the holding period return and the required return of the stock. So the required return that we input in the model when we price the stock is also the holding period return. In other words, the stock really does return 11% if you buy it at PO and you collect D1 and sell it at P1. So here's a question. You can repeat what we just did. Pause it now, repeat what we just did, and come back and check your work. And here are the answers. PO is $17.17. The price now is $17.17. We expect the price in a year to be $17.68, which should be 3% higher, right? Because we've learned the dividend growth rate is the price appreciation growth rate. And therefore, the holding period return is the dividend yield, D1 divided by PO, plus the price appreciation yield, P1 minus PO divided by PO. So 6% plus 3% equals 9%. The dividend yield plus G equals RS. So when you do a problem and you're given, remember we were given RS and we were given G, you could actually calculate the dividend yield by just taking RS and subtracting G. So that's something you might want to run through a few times and make sure you're getting the right answer. And just a little bit something extra to do today since we had the time. Thank you.